Okay, we're going to jump to chapter 9 now and talk about linear inequalities in one variable. So the solution set of a linear inequality in one variable is the set of all real numbers that make the inequality a true statement. So when we have equations, we see one single solution. An inequality has a whole range of solutions that can be graphed on the number line. So we have to understand the inequality symbols and their meaning so that we can write and graph the solution set. So if the symbols are listed in this table, and you can reference those. So when graphing a solution set on a number line, if the boundary value is included in the solution set, use square brackets at the boundary point. So like that. If the boundary value is not included, we use regular parentheses at the boundary point. So the solution set of a linear inequality in one variable is often written as an interval, which is a range of numbers with a lower and an upper boundary. If the solution set does not have a lower boundary, we use negative infinity, and if it does not have an upper boundary, we use positive infinity. And when we get to the examples, we'll see how we actually write the solution interval. So for example, the solution is the set of all numbers that are less than -3. So we go to -3 on the number line, and it says less than. So that means that the -3 is not included. So we put an open parentheses and then we shade in the less than direction, so to the left. So if we want to write that solution as an interval, it starts, we always do the lowest number first, so it goes to all the way to negative infinity. So we put a negative infinity. Now, why did I write a parentheses? Well, we can't ever actually get to infinity, so negative infinity. So negative infinity, or positive infinity, we always use parentheses instead of brackets. And then we put the largest value it can be, which is -3, except it can't, so that's why we use another open parentheses, just like we did on the number line, instead of the square brackets. So let's try number 2. If you want to pause the video and do it yourself, that's fine, and then check, or you can just watch. The solution is the set of all numbers that are greater than or equal to 1/2. So this time, first of all, we need to make a 1/2 mark. And our solution set is everything that's greater than or equal to. So since 1/2 is included, we're going to use the square bracket this time. And greater than means we shade our number line in the positive direction. So this time our interval goes from 1/2, which is included, so we use a square bracket, and it goes forever to infinity, and that gets an open parentheses. Okay, let's move on to the next page. So now we have solving linear inequalities. So an inequality is a statement that two expressions are not equal. So instead of an equal sign, linear inequalities contain one of those 4 inequality symbols from the previous page. The rules for solving linear inequalities are very similar to those for solving linear equations. The only big difference is if you multiply or divide by a negative number on both sides of the inequality, you must flip the inequality symbol. So we'll talk about those when we get to some of the examples. All right, so let's check out an example. So we have 1 minus 6x is greater than or equal to 13. So we solve for x just like we would if there was an equal sign. So subtract 1 on either side of the equation, and that leaves us with negative 6x is greater than or equal to 12. Now we have to divide both sides by a negative 6. And this is where that rule about multiplying or dividing by a negative number comes in. So we say x is now less than or equal to negative 2. So how can we check this? Well, let's pick a number that's less than negative 2 and plug it in and see if it makes the statement true. So if we have 1 minus 6 times, let's just pick negative 3. Negative 3, and we need to know if that's greater than or equal to positive 13. So we have 1. Negative 6 times a negative 3 means plus 18. And we need to know if that's greater than or equal to 13. And of course, that gives us 19 is greater than or equal to 13. So that works. So what would have happened if we had forgotten to flip the inequality sign to the other direction? If that were true, we would have come up with x is greater than or equal to negative 2. So let's check that statement. If we pick a number that's greater than negative 2, I don't know, say 0, we would have 1 minus 6 times 0, and we want to know if that's greater than or equal to 13. So we would have 1 minus 0, and we need to know if that's greater than or equal to 13. And so we would have 1 greater than or equal to 13. Well, that's not true. That's why we need to remember to flip the inequality symbol when we multiply or divide by a negative number. So then to graph this, we would draw our number line. And I know the number lines on the previous page had lots of numbers on them, but I'm sort of lazy, so I'm going to say that our number that we had was a negative 2, and we said for our solution that x was less than or equal to negative 2. So since it included negative 2, I'm going to put the square bracket and then shade in the less than direction. So our interval solution is negative infinity to negative 2. We never include negative infinity, so it gets a parentheses, and we did include negative 2, so it gets a bracket. Okay, let's look at number 4. So for this one, we definitely need to get rid of the fractions. So this 8 is like an 8 over 1. So we have 3, 5, and 1 in our denominators. So our LCD, the least common denominator, is going to be 15. So I'm going to multiply everything by 15 over 1. So, sorry, I should do that in black. So I'm going to multiply the first term by 15. And the second term by 15. And the right-hand side of the inequality by 15. So when I do that, in the first term, 3 goes into 15 5 times, and 3 goes into 3 once. 5 goes into 15 3 times and itself once. And there's no simplifying on the right-hand side. So that gives us 5 times the quantity x plus 1 minus 3 times the quantity x minus 1 greater than or equal to 15 times 8. So let's start simplifying. We have to distribute, so we have 5x plus 5 minus 3x plus 3 is greater than 15 times 8, which ends up being 120. So combine like terms on the left-hand side. We have 5x and 3x. That gives us 2x since the 3x is subtracted. And we have 5 plus 3, so plus 8 is greater than 120. Now we subtract 8 from both sides. And that leaves us with 2x is greater than 112. And then divide both sides by 2. So x is greater than 56. Now, I did not flip the inequality symbol this time. Why? Because I divided by a positive number, not a negative number. Okay, so let's graph that. I'm going to do it down here because I ran out of room up there. So for our graph, we have, let's see, 56. And we're going greater than 56, and 56 is not included. So we have a parentheses, and then greater than 56. For our interval, we have 56 to infinity, and neither one is included, so we put them in parentheses. So that's the end of section 9.1. Now we'll pick up with section 9.4 in the next video.